Physics 1 with Gus. Today, we're going to be solving the Gaussian integral. It's famous in quantum mechanics and statistics. It's also known as the bell curve, the normal distribution. And this is the base function of it. So you may have seen it like, there's some constant. I think it's 1 over square root of 2 pi something. I don't remember. But this general integral, if you integrate it, right, if you integrate this function, you get the square root of pi. What we're going to be doing in this video is we're going to say, okay, let's scale it. And let's use our intuitive understanding of what integral is to see what this integral should be without actually integrating it. And then we're going to integrate it to prove it. So basically, it's really not that difficult. I have this alpha times this variable, right, which affects the rate of change of the function, which means it's going to cross the x domain at a rate alpha faster, right? So it's going to go through this a little bit quicker by rate of alpha. So this is going to be compressed, right? So I'm saying, okay, if I have an alpha up here, this answer, the square root of pi, it should be smaller. But by how much? Well, it should be proportional to alpha, right? It should be proportional to the rate that it's changing. So I'm going to guess that the answer is going to be pi over alpha. I'm just going to guess that the integral is going to be something like this, right? Could be off by a factor of 2. Let's integrate to actually see. But this is how, right, I'm gonna use my intuition to say, okay, what is this integral? What should it be? So I make sure that my answer makes sense in the end. I have some understanding of what the answer should be. And it's very important in physics and math to actually have an idea of what the answer should be. This obviously comes through practice and understanding of functions and that kind of stuff. So let's get started. Let's get right into it. Here we have the Gaussian integral where we have minus alpha x squared. And I say u sub. Well, u sub won't work. If I use u sub here, I will get u equals alpha x squared. And if I take du, it's going to be alpha 2x dx, and I have nothing here to cross out the alpha with, or the x with. So what I do notice is that this integral is equal to some number, right? And we actually know that number is going to be something related to pi. So I can call this integral pi. It's going to return some value, some constant value. But I can say, hey, let me rewrite this integral. It'll give me the same value, the same exact value. But I'll just call what we're integrating over y. So you can see if I integrate both of these, it'll give me the exact same answer. But one just integrating over something called x, and one thing is I'm integrating over something called y. And what I'm going to do now is I see that if I can somehow manipulate this to get x squared plus y squared, I can transfer my coordinates from the x, y world to the r theta world. And I know that in the r theta world, dx dy is equal to r dr d theta. And then I'll be able to cross out that issue I had with u sub, right, where I didn't have that extra x. So that's what I'm going to try to do. I'm going to try and see if I can manipulate this to give me something like that, where I can then use u sub. So I'm going to say I squared is equal now to the integral minus infinity to infinity. I'm going to stop writing these minus infinities to infinities. So we'll just do minus alpha squared dx times the integral of minus alpha y squared dy. And well, okay, I see that these are independent of each other, which means I can bring the integrals on the outside, right? I'm not seeing like an x here and that kind of stuff, right? This is just a function purely of y, and this is a function purely of x. And that's what I meant. To make it more clear, e to the minus alpha x squared e to the minus alpha y squared dx dy. Well, okay, I can use exponential rules of exponents to now make these one exponent, where I have now the double integral, and I will write the domain now here over the domain, which is where the function exists, e to the minus alpha x squared plus y squared dx dy. And if you're looking at what I did, so I said I can rewrite this as the sum on the inside, right? So for example, if I had x squared times x to the fifth, x cubed, that's the same thing as x times x times x times x times x, same thing as x to the fifth. So I just added what's inside. For those of you maybe who are not, don't do math like all the time. Okay, so now I have this, and I see something beautiful. And I mean beautiful. Right here we have r squared. It's a perfect perfect polar coordinate integral, because I'm going to get an r here, which means I'm going to have the exact same integral I had above, but times that r that I needed. So let's now change from xy to polar. So we're going to go from polar to polar here. So we're going to get integral now over the domain, and we're going to talk about what this new domain is going to be. E to the minus alpha r squared. Now dx dy is equal to r dr d theta. So r dr d theta. Now let's see, okay, what are we integrating over now? Is the domain the same? Well, now we have to think about what does xy coordinate system look like, right, compared to polar coordinate system. So this is polar in red, and this is xy in green. So to describe a point in Cartesian coordinates, right, xy, I just say, some point x naught, y naught. And that could be negative infinity in the x direction, negative infinity in the y direction, anything, right? But in polar, when I want to describe a point, I give myself some radial distance away from the origin and some angle from the x-axis. Which means what? If I want to go in the negative direction, I say something like pi, right? And this angle can go around from 0 to 2 pi. So the range now is 0 to 2 pi, not negative infinity to infinity. So this is from 0 to 2 pi. And if I want to describe a radial direction that points, again, say from here, like over here in Cartesian, I describe it how? I say, okay, that's some, it's close to pi, right? And r is some length, right? It's not negative, it's positive. So r can go from 0 to infinity. So that's a new domain. It's over, right, everything that exists. And if I want to do it from xy to r theta, right, I have to consider how does this coordinate system describe points. So, okay, so now to write our integral, we can set it up by realizing now theta can only go from 0 to 2 pi, right, and that's the whole domain of theta. And r goes from 0 to infinity, and that's the whole domain of r. We've now transformed our integral from the dx dy world to the dr d theta world. So we're going to try to u sub this integral, so we're going to let u equal minus alpha r squared, and then we'll let du equal minus alpha 2r dr. So now let's substitute that in here. Now we see that this u sub doesn't affect theta, so theta is still going to go from 0 to 2 pi. And we're going to look here, we're going to say, okay, how does this u sub affect r? R starts at 0, so minus alpha times 0 is still 0. And then I say, okay, r is now infinity, so infinity squared is infinity times alpha is still some infinity, and then negative times infinity, so okay, now it goes negative infinity. Okay, so we have now e to the u, and we see that the r's are going to cancel, so we're left with du over alpha. Oops. We have a minus alpha 2 d theta, and let's make sure I didn't miss anything. Perfect. So now I'm going to bring out the, I'm going to use the negative to flip the integral, and then factor out 1 divided by 2 alpha, 2 pi, and now flipping the integral, so it's going to go from now like this, e to the u du d theta. Okay, perfect. Now I say, okay, there's not really theta in here, so if I integrate theta, I'm just going to get 2 theta. The 2's cancel, so I get pi over alpha. Pi over alpha. And now I'm left with the integral of minus infinity to 0 of e to the u du. And this is a beautiful integral because the integral is equal to itself. E to the u minus infinity to 0 alpha e to the 0. Well, this is 1. And then I get a minus 1 over e to the infinity. And that's 0. So I get pi over alpha Oops, might be just like pi over alpha. Okay, so what is this equal to? Well, we said up here when we started way back here, we said we called this integral I, and we called this integral I, right? And then we said I squared. Oops. Okay, so this is now equal to I squared, because we said we times I by I. So the solution now is this is I squared, which means I integral is equal to the square root of pi over alpha, which was our initial guess.